Okay, so the last section here in Chapter P has to do with the regression equations. We already did this, but we only did it for linear functions. So we need to be able to understand when we have to choose whether the data is linear, quadratic, or cubic, how to figure that out. So I did put all the directions here again, but it's much better if you don't have to read through those step by step, if you just understand what to do. So we're just going to get ready to do this problem down at the bottom. Anytime you're going to do regression, you're going to want to go to y equals, and you're going to want to just clear out whatever you've got. So that's the very first step for regressions, is to make sure that y1 is completely clear, and y2, y3, everything. So the problem that we're going to be doing is this one down here at the bottom. And it says a group of 13 people collected the following data, which represent their heights, x, and their arm length, y, rounded to the nearest inch. Find a model to represent the data. Use the model to predict the arm length of a 5'5" person. Then use the model to predict the height of a person with an arm length of 31 inches. And then what is the r² value of your model? All right, so we're going to go ahead and put in all these data points. Remember to do that. You go under Stat. Then you're going to go to Edit. If you have anything in there, you're going to want to go up to the top and clear, Enter. Make sure those are cleared out. Now we're going to go ahead and put in all these x's. So go ahead and put in all the x values. And you want to make sure that you have in the right number of x's. We have 13 people, so we should have 13 entries, and I do. Now we're going to put in the arm lengths, which are the y values. You always want to make sure that you have the same number of x values as y values, because if you don't, then it's going to give you an error message. The statistics must be matched up in order for it to be, the calculator to be able to calculate the linear, quadratic, or cubic regression. What do you guys think we would have if we were doing this kind of comparison, height to arm length? Would you think it's going to be linear, quadratic, or cubic? Linear? Most people saying linear. So what we want to do is look at the data, because by looking at it, we can kind of tell which one it is. We know if the data goes like this, it's going to be quadratic. If it goes like that, it's going to be cubic. So to look at the data, we have to turn on the stat plots. The quickest way to do that is to just push y equals and just make sure that plot 1 is on. Whenever it's highlighted, that means it's on. So mine is already on. Let's say it's off though. I go up here, I push enter, it's off. Go up here, push enter again, and now it's on. Okay? Now we want the calculator to compute the linear regression for us, if that's truly what it is. But before we do that, we want to see our points. To see our points, we're going to do a zoom stat. There are the points. Since they keep increasing, you guys were right, it is going to be linear data. So now we're going to go ahead and quit out of there, and we're going to do stat, calculate. We could use any of these. We could do linear, quadratic, cubic. Let's just say we weren't sure and that we chose quadratic. I want to show you what happens. If I choose quadratic, I'm going to go down here to calculate. look at this r squared value, 0.906. This could be then considered quadratic because anything above 0.9 for r squared means that it could be represented by quadratic. But logically thinking, if we have taller people, are their arm lengths going to all of a sudden get shorter? No, because it's related that way. Yep. So if r squared is not showing up, it's because your diagnostics aren't on. So I'll show you how to do that. What you want to do is go to Second Catalog. So Second Catalog is going to show you everything possible on the calculator. You have to go to Diagnostic On. Rather than scrolling all the way down there, because this has everything, to get to the D's quickly, just hit this button right here where the D is, and then it'll take you down to the D's. Go to Diagnostic On, push Enter, and push Enter again. So you'll never have to do that again. Now your diagnostics are always going to be on. Okay, so I went to Second, 0, went to Catalog. I'm okay for today. I don't call them. Can you tell them? So we're going to go then, we're under Catalog. We want to jump down to the D, so we push this button. And we're going to go to Diagnostic On, push Enter again. Got it? All right. So it kind of looked like it almost could have been quadratic based on that r squared value, but logically thinking, we know it's not quadratic because it's not going to go back down again like that. All right, so now we're going to go to Stat, Calculate. We know it should be linear, so we're going to go to linear. Then we're going to go ahead. I want you to be able to store the regression equation. So to store it, we go to vars, yvars. It's a function, so we're going to push Enter, and we're going to put it into y1. So that means after I push Calculate, all those values are going to get stored into y sub 1. Now, see how our r squared value is 0.904? That's fine. Okay, as long as it's above 0.8, that means it's fairly good representation. Go ahead and hit Graph now. So this is the line that best represents our data. It may not even go through any of the points, but it's best representing all the data points. It's averaging all the slopes, it's averaging all the y-intercepts. All right, so we've got that. So now let's answer the questions. Find the model to represent the data. So we're going to go back to y equals, and we're going to have to do some rounding. I don't want to write all that down, so we'll just round to the nearest hundredths. Actually, let's go to the thousandths just to be a little more accurate. So we're going to do 0.492x minus 4.972. So that's my equation, but the equation that I have in there is actually better. It's more accurate. So I'm just going to use that. So for part B, use the model to predict the arm length of a 5'5" person. So that means I'm trying to find y when x is 5'5". So all of our data was in inches, so what am I going to use then? 65 inches. Here's one way to do that. I do second trace, calculate a value when x is 65 for 5'5", and I get 27.0. So for 5'5" arm length is approximately 27 inches. That's one way to do that. Another way to do it would be to look at our table. So I would want to set up my table to start at that value I want to check. And now when I go to that table, second graph table, I can just look for 65, there it is, and there's my answer. That way it's even a little bit easier. Use the model to predict the height of a person with an arm length of 31 inches. So now they're giving us the arm length, and we want to know what the height would be. How can I use the table to figure that out? Yeah, I'm going to look for where y is about 31, and it looks like it's right in between there. So that's going to be about, we know 72 inches is 6 feet, so in between 6'1" and 6'2". Now let's say that we had to figure that out exactly, okay? So the way I could do it exactly is I'm going to go to back to y equals, and what y value do I want to have? Y value of 31, so I'm going to put in 31 for y2. Now I'm going to hit graph. So if I want to find the exact value, I want to know where is that blue function equal to the red function. So I'm going to do second trace calculate intersection, and I'm going to have to get there close to it. And then it's going to say, is that your first curve in blue? I push enter. Is your second curve in red? I push enter. Enter one more time. So 73.1. which it would be 6 foot 1.1 inches. Okay, so that's even a better answer still. And then in part D, it asks us what was that r squared value. I'm just going to do it again real quick just to get that. And our r squared value was 0.904. Okay? Any questions on that? All right, so that's the end of our Chapter P material. The quiz will be over sections P3 and P4, so you'll have your graphing calculator problem.